Let's start to create our backend server, or let's say our web server, where we will call our APIs to the client. After we have opened our Visual Studio Code to the folder, backend folder, as we structured it before, we run a command npm init. In npm init, it will ask us for a package name. I put eShop, a version, I press enter, description, let's say some backend of the eShop, for example, and then the entry point, like where the application will start, I put app.js, and then another comment. We keep pressing enter, and then it will ask us everything is okay. We press enter, then we will see a package JSON is created. So let's create now our file app.js, where we will start our entry point of our application. So I will put here, for example, console.log hello world, and then it will print hello world when I am running this application. But how we will run this application? I advise to use a library called NodeMon, which is a utility that will monitor for any changes of our source code. When we press Ctrl S or save this application.js, it will restart the application again automatically. So after we install this library, we see it is in dependency in a package.json. As a custom script, we can add it here, like it's a command to start the application using node monitor. So I can say start node monitor or nodemon app.js. In this case, I will have the application started with the entry point file app.js. Let's try it now. Let's save app.js and then write npm start. And after I start the application, I will see hello world. And the application is still running. So it's detecting any change I do in the application. So I say hello world with a change with exclamation mark, and I see it's changed. Let's change the world eShop. We will see hello eShop. That's great. So till now we have only a running application, but we don't have any server yet. So to create a web server, let's install Express, which is a famous library from Node.js, to host a server. So after doing this installation, I will see it also in dependencies, but let's remove this console log and create a constant, call it Express, and call the library Express using the keyword require Express. It will call it automatically from node modules. And let's create a const which is called app, and this app will call a function called Express, which we mentioned or defined before. This web server requires listening to a specific port. So I say app.listen, and I specify, for example, 3000 as a port, and there is a callback. Callback will give us or will be executed when there is successful creation of the server. So in the callback, I can print any message in the console. For example, I will say the server is started now, or the server is running now on the link localhost with 3000 port. So now let's run the application again. I will say npm start, and we will get some error because I am running this server already. So let's turn it off and I run it again. I will see localhost, or the server is running on the localhost 3000. When I open the browser and visit this URL, localhost 3000, let's see what we will have. I put it here and I see that cannot get. Cannot get because I didn't specify any initial route for the application. We create now the initial route or the route. We can say app.get, we will see Express is providing us with all HTTP requests, for example, put, delete, and also post. So for get, it will accept two parameters. The first one is the route itself. For example, I will say the initial route or the route. So in this case, I will ask for a callback. The callback will have the response which I will send to the client when he will call this route. So I say in the callback response.send, for example, let's say a message, we can call it hello API, not hello world. So now we have this API, let's save, and now we can run the application again on the browser. The application will call a get method and we will get as a response this hello API. So as a recap, we saw how we created our own server or web server with Express, and we were watching our changes with Node Monitor, and how we call this application get to initialize the route, and we run the server under a specific port. We saw before, we need to have an API and a version in the URL of the route. So let's see how we can create that with environment variables in the next lecture. Okay, so let's start with environment variables. Environment variables normally are used as a public variable which are used among the application. So for example, I want a public variable for API URL. So this API URL which will be prefixed for every route which I use for my application or for my API. So as we saw before that every API we had, it's prefixed with something like /API/version1. And this it means that every API in my application will have this URL and then API version 1, and then I say, for example, products, and then I can post, delete, or create some data to this API. So now let's see how we can read this prefix. So I don't want to repeat in my APIs always this string. So I can fix it in some constant which is readable from everywhere, and then I can pass it to my strings routes, and then it will be readable in that route. So to do that, first, normally in Node.js, normally we have an environment variable called .env or environment file, and for example, I pass a variable name which I want. It's any name you can have it. For example, API URL, and then I can say the string which I want to pass, which is API/v1. And in this case, I will have this API URL is defined everywhere in the application. But first, how we can read this variable from this file in our application? There is a library, we can install it from npm packages, and it's called .env. So we can say npm install .env. And this library normally is available always, and we can use it in the application JS, in the root, no problem. So we can say define, or we can say require this library. So .env /config, and normally this should be in a string. So when I say require this library, then I will be able to use some specific constant to get these values from the env file. So I will go here and define a constant. Let's call it, for example, API, and then we can say process.env. Then the name of the variable which I created here. So I can say API underscore URL. So let's save everything. And now let's try to print this variable to see if it's really reading from this file or not. So let's do it on when we start the server. So I will say console.log the API constant. So then I will start my server npm start, and here it is. We have it now defined already. So in every route I can define or pass this API variable plus the route which I want. For example, products. So in this case, I will have the prefixed API version 1 plus products. We will see that more in detail in the next lectures to see how to create the route and how to build it and how to call it. The most important thing you need to know now that we can create a public variables in this file and read them anywhere in the application. So in this case, I want to store, for example, the database string or connection string. I can store it here in this file, and also, for example, some secret for authentication. I can also store it here. And when I want to deploy the application to the production server, I'm going to change these variables. So we will have also another file, for example, .env, but for production server. We will see that, of course, in the lecture where we will deploy the Node.js application. So now let's move to the next lecture where we will create the real API and how we will send JSON data through it, because we need JSON data for our eShop to exchange with the front end the information about the products and the order and etc. Now we are going to see how to exchange data between front end and the back end. We saw previously how to exchange data with the front end with GET request, so we send hello API. But what we did is only exchanging a string, which is hello API. So we need to exchange JSON data. For example, the product is an object consists of ID, name, image, and price. So now let's simulate the product's API. So at first, let's have the nice prefix as before. So I am going to use the backticks, which are very helpful to combine between constants and strings without using this plus. So now let's remove this part and create a backticks, and with a sign $ and curved brackets, I will make API and then let's say products. Let's remove this part from here and also this one. And I'm going to create a constant, let's say product, and this product is object, contain ID, let's say 1, and name, let's say hairdresser, and image with, for example, some URL. So you have option here to select double quotations or single quotation, but with JavaScript it's better to use always single quotations. In the response, let's send this product to the front end, and we will run the application. Now we have the application running. Let's go to Postman. Postman is application as we talked before, and we saw how to install it. So I can call APIs like with get methods, post, put, etc. So let's have here our API 3000 and then API / version 1 / products. And I click send. Then the response is the object which I created already. So we assume that we are building this object by getting the data of the product in the database or from the database and then send them to the front end with the get method. So what if the user or the admin of the application of the eShop will send or, for example, create a new product. So the new product need a data which will be sent from the front end. So now let's change this method from get to post. For example, I will copy it and say post. And the post requests need also data. this data will come from the front end. So how I get this data from the front end? It's very simple, by using request.body. So after posting the data of the body, I am going to send them back to the front end. So let's create a constant, let's say a new product, and this new product will be request.body. So let's make it like this, console.log the new product. So we go to Postman. In Postman we change this method from get to post, and the body of the request will be, for example, a JSON row, which is JSON, and then I can pass, for example, this object. And when I click send, we see that we return 1. And in the console log, I got undefined. So the problem is that the body is not parsed well. So we need something called a middleware. The middleware is a function that has control of the request and the response of any API. So when the front end sends JSON object, we need the back end to understand that this is a JSON. So please analyze it and use it in the back end. Doing that is done by a library called a body parser. So this body parser, we can install it from npm packages, npm install body parser, and this body parser we will call it with require method. So I say const body parser, and this body parser comes from require body parser. After that, I will make a special section for calling the middleware APIs or the middleware methods. So let's say here we have a middleware, and in the middleware I will say app.use the body parser dot JSON. So in this case, my application or my backend will understand the JSON which is sent from the front end. So back to Postman, after running the server again and post this body data, let's say send, we will see that we return this data. And in the console log, where I console log this data after the post request, I see that this data received by the backend. So now we are able to make a get and also post of the data. I will, for example, change here hairdresser 2 and send it, and I will get back the hairdresser 2. So now our API is ready. We are now starting to build this API structure for orders, for products, and for users, as we talked before in the previous section. In the next lecture, we will see how to log these API's events. For example, when someone posts data or get data, we will log them in the console of our application. It's very helpful for the developer to know what is going on his server, so we can know and log the HTTP requests which are coming from the front end, like posts, get or put or delete. To do that, there is very good library called Morgan, so we can use it to log our HTTP requests which are coming from the front end. So let's install this library. I stop the server. I say npm install Morgan. And after installing this library, we can call it also with require. So const Morgan require Morgan. We said this library is a middleware library, so we have to put it in app.use Morgan, And there is some default options which is called tiny. This is good in case to display the log requests in a specific format. For example, let's run the server again. npm start. So we have here the server is running. With Postman, let's do some request. For example, I am going to send the post again. Okay, back to the application or to the code. We will see that we got a post request on the API and with a specific status number. Let's make a get also. Here is a get. I send and back to the application, and I see that I logged also the get request. There are many options for this library, so you can format your logs as you want. But we are not going to do that. We are going to use only tiny. And of course, you can save these logs on some files. All of this is displayed here in the documentation of this library. Now we were using only a fake data of the product. Let's start to bind this data to the database. So let's in the next lecture to do the connection to the MongoDB using Atlas. Previously we saw how to fake a data of the product to store them and display them in our application. Now what we need is to store this data in the database, and in this course we are using MongoDB. And as we saw before, we don't need to install any special software for MongoDB. We just need to log into the cloud of MongoDB, and then we create there our database and connect our application to that database in the cloud. So first of all, how we can connect our application to the database on the cloud. So first, we need to install a library called Mongoose. Mongoose is responsible for all operation of MongoDB database in the application or in Node.js application. So let's install this library, which is called Mongoose. I will type here npm install Mongoose. And as every library, we need to create a constant. Let's call it Mongoose. And this Mongoose, we can say it's require Mongoose. We can assume that this thing here is like import. So we are importing every library and store it in a constant. Normally, we add the connection to the database before starting the server. So here I will say mongoose dot connect, and in this connect it's asking for URIs. URIs or connection string, I can get it from MongoDB Cloud. We saw previously how to connect to Cloud of MongoDB and create our application and clusters and our project. And we saw that we have multiple collections, or we can say databases, and those databases, we will have access to them through our application. So let's see how we can connect to those databases. In clusters, if I go back to clusters, I see here a button that it says connect. When I say connect, I can use multiple options from MongoDB. For example, what we need is connect your application. So we need to use a connection string to get it from here and paste it in our connection method from Mongoose. So by clicking on this option, we will get a connection string. Let's copy it and have it in our application. So I open quotations here and copy this connection string. But we can see it says these connection strings should contain a username and password and database name. But from where I can get these informations? Simply, in MongoDB Cloud, we can use a specific users to connect to these databases. We just need to go to Database Access and create a new user. And with this user, we can connect to database in the cloud. So let's click here, add a new database user, and let's give it a username eShop user. And the password, you have freedom to select any password. For example, I put from 1 to 7. He said the password is provided is very weak. So let's add some letters to it. And then it successfully added the user. Going back to our connection string, we need to replace this data here. So first, I will put here the username, eShop user, and the password which I had before, and the database name. Okay, we don't have database yet, so let's add one. We go back to the clusters, and then we can see here our collections. And in this list of collections I have previously, I can create a new database. So I'm going to give it a name, eShop database, and the same name for the collection. Back to the connection string, we can add now the database name. So now we have the full connection string. We talked before about environment variables. So let's store this string in the environment variables. So I copy it, and then I create, for example, a variable, call it a connection string. And then I give it this value, which is the string which I got from the database cloud. And here I just say process dot environment variable dot connection string. So now how we can check that we are connected to the database or not? If we check this method connect, we will notice that it's returning a promise. The promise normally is getting executed and it's returning two methods. One is then, when it's success, and one with the error when it's fail. So here I will put then, and this then is a raw function, and I console in the log some message that database connection is ready. And when it fail, on catch, and it's also a raw method, we can say console log the error. Let's try to start our server. So now npm start, and we see that there are some notifications saying that deprecation warning. It's saying that current URL string parser is deprecated. So we need to use some specific variable. So we need to use a specific option as a true to make this deprecation disappear. But how we can use it? We see this connect method has another parameter called options. So with this options is an object where I can pass the options which I want. So let's copy this one and add it as option. We got also another deprecation warning, which is use unified topology. This is used also for searching for the servers. So let's add it also here, and let's save. We are still getting error. Actually, the error we need to pass also the database name in the options. So I can say there is some reserved word, it's called db name, and with this db name I can pass the database name. We named our database in the cloud as eShop database. And after saving and trying to reconnect, we see again that the authentication is failed. In MongoDB Atlas, you need to give a network access. So this network access, you need to have a whitelist of IPs which can access your database. So I have two IPs already. I can add another IP by going, for example, to Google and just type, what is my IP? And in the first search result, I will get my IP directly. So I go here, copy this IP, and then I say add the new IP. So this IP is added. I can say my home office. And then I click confirm. So back to the application, we can see if we are able to connect or not. So just we can press save again. And we see here the server is running, but we didn't get any response yet from the database server. And we see that the database connection is ready. So in this way, we connect the eShop backend application to the database in the cloud. In the next part, we will see how to write data to this database using our APIs, which we created before. Perfect. So I am so glad now that we have a successful connection to the database. Let's now try to post some data to the database so we can see them in the MongoDB cloud. In the relational database previously, we saw that the relation between the tables. But here in MongoDB, it's quite different. We can consider the naming table is a collection. So as we see here, we have already a database, and inside this database, there is a collections. So we can say the collection is a table in relational database. I deleted the database which we created before. I'm going to create a new one with a table, let's call it a products. So for example, we said that our database name is eShop database. Products is the collection name. So I have the database, eShop database, and inside that there is a table or a collection. We can call it a products. Okay, great. So now we have, let's say, this collection. Let's post data to this collection. So in Postman, as we saw before, we have here this object. Let's push it to this database. But first, what we need to do in the Node.js application. We need to create a model with Mongoose. Model is the same thing as a collection. So we can say in MongoDB, it's called collection, and in Node.js, it's called model. So we need to create a model of product. This model will contain the columns which we needed for the product. For example, the name or the image, or for example, the quantity of the product in the storage. In Mongoose, this is called schema. And if we go there to the documentation, we see that Mongoose has a lot of flexibility here. So we can create schemas, for example, blog schema as we see here, and we can put the fields, title, author, body, and there is type of it. And every field has some options. So you can specify, for example, date.now. For example, when this record or this document is created, then we will see that it takes automatically the date of time of current time. So let's start simple. So let's first create the product model. I go to the application, and after, let's say, use and before the APIs, I create, for example, a constant, call it product schema. And this product schema will use Mongoose library and schema. And this schema accepting an object, and this object will take the fields as we saw here in the documentation. So we have a new schema, and here we can list our fields. So let's add our fields which we had before. So I say I need the name, which type is string, and for example, I need also image, which type also string. It will contain the URL of the image. And let's add also something like count in stock. Count in stock. And this count in stock will be a number. There are a lot of types. You can check the documentation of Mongoose, and we will see in the course the different types which we will use for our web shop application. After having this schema, we need to create the model. So I say constant product. Normally the models start with capital letter. So we can say product, which is mongoose.model, and the model called, or the collection is called product, and using the product schema which we had before here. So I say product schema and I press save. Now we have the product schema and the product model already defined. So now we need to, for example, with posting request, we need to receive this post data from the front end, which is, we can say Postman or any other application like Angular or React. And then we need to receive this data by the back end, analyze it, and push it to the database. To do so, we need to create a new product, for example, of that model. So let's do that. We can say const product, and this product is new product which we had before. But what are the fields of this product? So the product is this model which we had before, and we are going to add the fields of that product, like the name and the image and the count in stock. So I will go here and I will receive the request which I got. With this request, I get the body. And with the body, within the body, I am sending here ID, name, image, and I can send also count in stock. It will be exactly the same naming here, which comes from the front end. So the front end and the back end must agree on the same naming for the fields and the object which are sent to the back end. So here I say the name is request.body.name. Image is request.body.image. Count in stock is also from the request.body.count in stock. Now we have the model ready, so we just need to save it in the database. So to do that, we can say product dot, and it had a method called save. Save, it means that save it to the database. If we check this save method, it's returning a promise with the document. So we can say then it's returning a promise. So we can say created product. So this is the product after it got created in the database. So it's a raw method. So we can say here response dot status that it's successful connection or successful creation of the database of the document. So I can say here dot JSON. So I want to return back the created product to see it in the front end. And in case of error or anything can happen, we can say catch the error, and this error we can say response.status, for example 500. It's the response code for errors in the HTTP. .json, I create, for example, my own object. I say error is the error which I got, and for example, I say if it's success or no. Maybe I can use this variable in the front end, for example, to end some loading or go back to home page. if there is some failure. We already sent that product, so let's delete this part here and start our backend. npm start. We have it now ready and the connection is ready. Let's post some data here. Nice, it's posted. We got ID, name, image. So if we go to our collection in MongoDB, let's press refresh here. We got the same data here. Let's try again by adding count in stock. I say, for example, 500 pieces in my stock. I send it. I created a new product with the same name, and it's returning the ID of created product. Going back to MongoDB, refresh again. Nice. I have also two products already posted through my API in the backend. And we notice here that it's logged and successful. Let's make an error. For example, to make an error, let's make this field as required. So, database will recognize that this count in stock is required field. So it will respond with error that you didn't send, for example, the count in stock. To do that, we go back to the schema and we change this to an object. The type of this object is number and required is true. So let's save it and run our API, but without count in stock. And if we validate the JSON and send again, we will see that we received an error. Error and success false or failed. So in this case, I would say the error is validator error, path count in stock is required. So the database replied to me that this field is required. When I do it again, it's success. So now we have posted a data to the backend. Let's create a GET request. So I want to get this data, display the product information in the front end, for example. So to do that, we need to create a GET request. So creating a GET request, just simply we change this to GET, and we need to specify the products list. So let's, for example, get the all product list. And if I send a request, I'm getting the old API which we had before. So let's change it to have it from the database. To do that, we go to the GET request, and then we replace this constant and call it, for example, product list. And I call just the model itself, which we created before, and find. That's it. So I say const product list, and the response will get or send me the product list. Let's try that. We do a send. We notice that we got error here. The error is because that find method is returning a promise. And here, when I am sending the response, maybe this product list is not ready yet, and I didn't get it yet. So I need to wait until this product list is ready, and then I can send it with the response. There is another way than doing, for example, .then and .catch. There is something we can do with await keyword. And in the await keyword, it requires always async method. So I put this method here, and it's async, and I have await here. So in this case, when I call the product list, then it will wait, it will be filled, and then I send the response to the front end. So let's do it again now. I am saving and then sending the request. We see that we got the data here. We didn't get the error anymore. So this is because of that we return a promise. We should wait for the database to send us the response, and then we show it in the front end. So maybe you will ask me how I can detect the problem or issues. It's very simple. I can say if product list or no product list, if there is no product list, then I can say response.status 500. And for example, with JSON, I can say error or success false. So if there is any mistake happened, for example, connection or anything, I can simply return error with a success if this list is empty. So we have two different ways to express and catch errors from the database. So I can say here, find, I can put await and async, or I can do it with normal promises. Like for example, I say save, dot then, and dot catch. Of course, this is more code saving. We did this only in 2 lines, and that's very good. So from now on, we will use always async and await. That's all for now with Mongoose. Let's do some refactoring. It's very nice to have the routes in some files and the models in another file, so we can have more organization of our code of the backend. Welcome back. I changed my mind here, so we will not do refactoring. Let's analyze first the database of eShop. So in this way, we can know what routes and what schemas we can build and creating the files in the backend. So here we have list of the tables or documents or collections which we need in our database. Every eShop has products, orders, categories, users, and order items. This is the simplest eShop. So when you want to grow up more, you need to have more tables like reviews or, for example, some new categories or bigger categories. So we start simple and we will build our eShop to be bigger slowly. First of all, the products, for example, it has ID, which is the ID for the product. And this ID is generated when we post any ID to the database automatically by MongoDB. The name of the product and also description and the rich description. Rich description is used for example, I want to store some HTML code. Sometimes people are using as a description of the products with images and titles and some complicated rich texts. So we will see how we will have editor in the front end for HTML. We need also the main image of the product, and it's a string which will store the URL to that image. Also, we need a gallery. The gallery will have some images and array of strings of URLs where we have a gallery of the product, more detail about the product. And then we will have a brand and also price of the product. Category, it will be the type category. In MongoDB, here we will have something called references. It's not like relational databases, but here we can define the type of the table directly. So as we will see in the future, we will see that this category is a type of category or has a reference to the category table. And count in stock, how much items of this product are in the storage, also rating based on reviews, and if this product is featured or not. So to see it in the homepage immediately as a featured product. And then we will see that what day this product is created. For categories, we just need a name, maybe some additional data. For example, what I need in the front end sometimes color, so I can color every category based on some specific color, and also icon or image. For orders, we need order items, which is array of order item, and order item is a table where it contains the product and the quantity. So every order will have a product and a quantity. So maybe I will have 10 products, I ordered them in one order, and then every product will have some quantity. The shipping address 1 and shipping address 2 and city, zip code, country, phone number of the user, status to see if this order is, for example, pending, shipped or delivered, and also the total price we will see how to calculate the total price based on the order items and the user who ordered this order, because we will have login for every user who wants to order something, and then the date of the order. For the users, we need an ID, name, email, where the user will log in with his email, and a password hash. The password should be stored hashed in the database. I cannot store it as plain text. Street, apartment, city, and zip code, and also country with a phone number, and also to know if this user is admin, so he can log in to the, for example, admin panel or not. Maybe someone will ask why I separated here the address from the user. Like, for example, I can have extra table like address here, and then I can put this field in that table, and I can relate user and orders to that address table. Actually, most e-shops has a problem that sometimes user, after he orders something, he change his address, but the order is already shipped. So we need to store the order as a plain with the shipping address, how the user placed it, not related to the user address. We will use this address just to autofill the order address when the user is ordering something after he log in. In this way, we took an overview about our database in MongoDB. Now we will go to the backend and create the files and refactor our code a little bit to be based on this database structure. Welcome back. I'm imagining now that what if we place all the schemas here in this file app.js? It would be very big, and I think we will have thousands of lines here. So normally in Node.js, the people or the coders in general, they are putting these routes, for example, the API routes, and also the schemas in separated files. Let's do that now, and we will see how to organize the project more better way. So for schemas, let's create a folder here. We call it models, and inside model, we will create a file for every model we have. For example, products or product.js. In product.js, I will place this schema. So let's copy this part and place it here. Mongoose is not defined in this file, so we need also to copy this part where const mongoose require mongoose, because this file cannot see the imported mongoose in the app.js. So we have here const mongoose and mongoose with the schema. And by the way, let's get also the model. So we cut it and we place it here. Now, how app.js will use this model? In Node.js, if we want to export a constant or, for example, a class or object, we just say that we need to do it in this way. Exports dot product and then the model. So here, in this case, product will be seen in any other file, and I can import it with require method. So going to app.js file, and I say const product, which is coming from by requiring it from this file where we have the model, for example, models/product. In this case, we got the product and we can use it as a model for our API. Let's do more refactoring. We see that we have all the APIs, get, post. So if we do that for all the schemas, it will be a very big file. There is a way in Node.js that you can also store the routes or the APIs in separated file. I will show you how to do it. So first, let's create a folder, call it routers, and inside router, I create also products.js. So for every model, maybe there are routers. In Express, there is something called router, and this router is only responsible for creating APIs, storing the APIs, and importing and exporting them between the files. So how to do that? First, we need to import the Express, require Express, and the router will be part of Express. So we can say express.router. So this router, when I import it in app.js, I can use it here. And this router, it can be used as a middleware. So I can use it with app use. So first, let's see how to move these routers. So first, let's copy all the APIs we had and place them here. Instead of app, I just say router. That's very simple. And also, I delete them from here. And as we said, app.use, it can use also the router. So we can take the main API route of the products and place here, for example, product router. But from where this products router will come? It will come from here. So I can say, I want to export also the router. So I can go here and say module.exports is router. So we have here different way for exporting. Here we are exporting the product itself, and here we are exporting a module. So in this way, I can say products router is a constant. So we can say here constant products router coming from require from routers and then products. So we will see here that this application is using these routes from routes which are coming from products router. So here we need to do something. We cannot use the API like this because otherwise it will be, we can consider this as a children. So for example, here I need to place only the slash. So I can consider it when I say localhost 3000/products, then I can reach this one, get. And the same thing for the post. If I want something in the future like count, I put it like this. Then the API will be http 3000/products/count. So this is the best way how we can handle the routes in separated file. But first, we have here the model product, so we need also to import this model. So I say const product is require from models the product. Now we have the routes completed. So we have everything, get, post, and we will see how to add the delete and update. Let's save this file and also save it here. Make some more organizing of the code here. So we don't need this anymore. So we can here say routers, and here the product router. We can have it here imported. Let's see now if everything works fine. We can say npm start. Everything is connected and everything is working as smooth. The same thing will go also for the other database collections. For example, I will have here orders.js and also user and also the category. Also the same thing for the routers. I will have the same files. So I'm sure you are not interested to see all the process because it's exactly the same. I'm going to add them and then we will see after that how they look like. At the end, our application look like that. In app.js, we have the middlewares, routes, and also the database connection and the server. In the routes, I created routes for every type or for every collection we had in our application. So I go here and I created the routes exactly like the products. We have the users, orders, categories, and the same thing for schemas. Every schema has its own now. So in this case, we have now everything ready to create our APIs. Currently, I use only get in every type. I just want to mention one thing. When we export the model from exports.product in this way, not in this way, when we import it, we need to import it as an object. So here, when I go to the products, I import it like this. In ES6, we have this object destruction. So this model is returning an object. So I need to create a new object and assign all fields of that object to this one. So in this case, I can use it everywhere. For sure, there is no any problem if you use this way, the way of exporting the module directly. Let's try our API now. I go here and I say get. I got list of products. That's it for now. For next lectures, we will see how to fill these schemas and how to connect it to the structures of our database, and we will see how to continue to build our eShop in a better way. If you are doing a front-end and a back-end development in the same time, I'm sure you saw this error. This error called cross-origin resource sharing, which means, in a human language, that Node.js application cannot trust any other application. So when I am sending requests from my front end to the back end, then the back end will not respond to me the same data which I want because it's forbidden. It's using different port, which is totally a different domain. So in my front-end application, when I create a services to call the APIs, then I will get that error. And in Mozilla org, they are explaining all the data or all the details about this course. So somehow, in Node.js app, we need to enable those cores. How we can allow any application to request API from my server. There is a library called course. We can use it to allow the course for any application. So I stop the server and I say npm install course. After installing it, we need to require and import it. So here we are importing everything in app.js. So I say const course require course. And to enable the course, it's very simple. Before everything, before the application starts, before using any service in the application, we need to do app.use course and app.options with star like everything using the course. This app.options, it means it's some type of HTTP requests like get and post and put and delete. But what is it? When we Google HTTP options, we see that HTTP option is a method requests permitted communication options for a given URL to the server. So when I say I want a star, so I am allowing everything with using this course. So in this case, I am allowing all other HTTP requests to be passed from any other origin. So it's very important to use this course and enable them to avoid this error. Finally, after we finish this module or this section, I would say that this project is the startup for us for creating the eShop backend. So I will put it as a zip file so you can download it and start from here. You can see this project in the resources with this lecture. In the next modules, we will see how to build all the schemas and the APIs for every part of the application.